Hi everyone, welcome back. This is the 41st video in our series on building a chess engine from scratch in the Java programming language. We've spent a considerable amount of time fleshing out the basic components of a GUI, and prior to that building out the basic components of a chess engine, which included the pieces and their respective legal move calculation, the board abstraction, the players, and the move, and so I would say right now we have like the basics of a chess game working. In this video I want to focus on the special moves. I want to start with en passant, and I want to address some of the issues that we would have right now around moves. I also really want to emphasize that we have not, as of yet, dedicated any time in our video series on test cases, and that's really important. That's a very important part of the development process. So one thing that you could do is you could download from my GitHub all of the test classes and import them into your project and run the test code. I'll probably dedicate a video in the future to doing that, but if you want to get ahead of the curve and do that now, you can, and you might observe some shortcomings or bugs in the code that way. So I actually noticed a bug in the code. Let me see if I can fix my resolution just a little bit. If I run the program right now, and if I click twice on the source piece, so like I click and I select it and then I click again, we get this null pointer exception, and I debug this, and I would encourage you to do it too. But what's happening is that we're traversing through the list in order to do a list of moves to compare against another move, which happens to be the null move. And when we call equals, we're trying to get the current move coordinate on the null move, and that's basically undefined because get moved piece for the null move will return null. So the way to get around this is to say public and override get current coordinate on the null move and say return -1, right? So this is an invalid current coordinate for any given piece on the board, and this is a 65 is an invalid destination location, right? So that's why we chose 65 for that's what the second argument represents. So the null move, we got that part right, but we didn't override the behavior for the current coordinate. Notice we don't keep track of the current coordinate as on the actual move class. We delegate to the piece, right? So one thing we could have done, another way we could have addressed this is to have a null piece, right? Then we wouldn't actually have to hard code this at all. We could just pass in the null piece, and the null piece's current coordinate would be -1, and the null piece's destination coordinate could be 65. So maybe I'll do that in a future video. That's a refactoring that would make the code a little bit more cleaner and consistent. So if we run this code now, right, it doesn't matter how many times I click here. I'm clicking, I swear. It doesn't, I don't get a null pointer exception, and it works. But we know for a fact that move is a little incomplete with respect to all the move types. So I just want to walk through each of these from the top and see if there's anything that is missing that I want to address immediately. So I think that's okay, and let's look at major move. On major move, we are saying return, the toString for a major move returns that and the board utils.get destination coordinates. So why don't we uncheck this in? Uncheck that out right there. Okay, so that should be, that's good. Let's see, for an attack move, we should have, let me take a second here to look at my source base. That's correct. The hash code method's correct. Equals method looks right. And I don't actually have a, so we can get rid of the execute method directly on attack. We don't want to override at that level. We want to override on the subclasses. So don't think we need that. Is attack returns true, and the attack piece returns this dot attack piece. That's correct. So let's take a look now then at pawn jump. Don't think that's quite right. Yeah, probably will have a little bit of refactoring to do here. Let's see. Do I have a pawn jump class? Pawn jump, I do. Pawn jump extends move, that's correct. And so pawn jump is correct. I don't have a pawn attack move, do I? Oh, I do. So for pawn attack move, let's finish up this class. Sorry for taking too much time there. Let's see. Public override, public boolean equals final object other. Return this is equal to other, or other is an instance of a pawn attack move, and super dot equals other. And let's say, oops, public string to string. For pawn attack move, we want to say return board utils dot get position at coordinate, this dot move piece dot get position, and substring 01, and then include an X. This is PGN format. I'll explain this in a second. Board utils dot get position at coordinate, this dot destination coordinate. Okay. So now what you should notice before and after here, if we execute an attack, it shows now sort of right, we get the letter of the we get the rank for the move piece, and followed by an X, followed by the destination coordinate D5, right? So that now works. Okay, that's a nice little cleanup that we did there. So for pawn move, which extends move, let's see what we can do here. We want to say, bear with me here, guys. This is just a bit of cleanup that we've got to take care of here. Public boolean equals Final object other, oops, object other, and this is equal to other, or other is an instance of the pawn move, and super dot equals other. And when we want to show a pawn move, a normal pawn move, right, public string to string. Oops, sorry, a little off today. Public string to string, return board utils dot get position at coordinate destination. If we try to go up there, yeah, that's fine. So let's look at pawn. We got pawn move, pawn attack move. Let's look at major attack move. We don't have a major attack move. We have a major move. Okay. So we have attack move, major move, and let's introduce a major attack move. Public static class major attack move. This is a major piece executing an attack, right? Extends attack move. I think right now the major pieces, let's look at like knight. Yeah, we're just creating an attack move. We want a major piece's attack move. So attack move will become sort of a parent class for both the major pieces and for pawns to execute the attack move. So we can say public major attack move, final board, final piece move piece, piece moved, final int destination coordinate, and final piece attacked. Okay, and we can say super board piece moved, destination coordinate, piece attacked, right? And we can make sure that the equals method is correct and does the correct efficient comparison. Object other, return this equals other, or other is an instance of major attack move, and super dot equals other, same pattern we've been using, and override public string to string, and we want to say return move piece dot get the piece type, and follow that by a board utils dot get position coordinate, this dot destination coordinate. Okay, so that's what we will do there. And let's see. Okay, so let's see if do we have a pawn attack move? And is there any subclasses of the pawn attack move? There's the pawn en passant attack move, right? So this is where things start to get interesting, right? So this is, and I will definitely explain this one, public boolean equals object other, return this is equal to the other, or the other is an instance of upon passant attack move. And super dot equals other. Okay? And here's where things get interesting. We want to override the execute method. So we want to say public board execute, right? Okay. Okay. So this is where we're going to execute the en passant move, right? And so let's just start writing the code and then we'll explain it. Final builder is equal to new builder for final piece in this dot board dot current player dot active pieces. If not, this dot moved piece is equal to the current piece, right, as you're going through them. If it's not the current piece, then just go ahead and set it. Builder dot set piece, right? And for final piece in this dot board dot current player dot get opponent dot active pieces. If not, this dot piece dot equals this dot get attacked piece, then go ahead and just set it. Right? These are the easy things to just get them out of the way. Not involved in the move, basically. Then what you want to say is builder.setPiece this dot move piece dot move the piece, this, and builder.setMoveMaker this dot board dot current player dot get opponent dot get alliance, return builder dot build. Okay. So I believe that is correct when you're doing the attack, right? It's basically like an attack where the it's almost like a pawn attack move, right? So the only difference is that we've decorated it in this pawn en passant attack move, which we're going to use in the pawn class. Okay? So we'll see, once we see that, then I think it'll become much more apparent what it is that we're doing. So let's take a look at castle move. Castle move we I believe is working for the most part. Let's see what this to-do is that we have here. So I have a to-do, look into the first move on normal pieces. Yeah, that's not something that we have to do right now. Okay. Is castling move returns true, get castle rook. So let's, aside from execute, we want to have a hash code and equals method for a castle move, which we currently don't have. So, right, just kind of some loose strings here that we're tying up. Nothing too major to focus on. Public int hash code, final int prime is equal to 31. Int result is equal to super dot hash code result is equal to prime star result plus this dot castle rook dot hash code. Nothing special going on here, just the hash code and equals methods. Prime star result plus castle rook destination, just a function that uses all of the constituents of this move. Return result, right? And public boolean equals final object other if this is equal to the other, return true. If not other is an instance of a castle move, return false. Finally, other castle move equal to castle move other, return super equals other castle move, and this dot castle rook dot equals other move, other castle move dot get castle rook. That's it. And actually, yes, we don't have to put the castle destination there because that will be captured by the comparison of the rook and the move that's returned from the piece. Okay, so the kingside castle move, we've got the constructor, and we've got the two-string method, and the only thing I think we want to capture, the only thing I think we need to capture here is, actually I don't think we need to do anything there. I suppose what we could say is this, we could say override public boolean equals, can say final object other if this is equal to the other, return true. The usual pattern that we have, return, where's the pattern? Like something like that, right? If this is the other and the other is a kingside castle move, and super equals other, right? And super will go to castle move, and that should be fine. Right, and the same thing is true for the queenside castle move. So bear with me here. Some boilerplate code that we had to go through in this video. Not fun. All right. And this should make things a little bit cleaner in the move class. And this is really setting us up for what we want to do with En Passant. So let's see, it's definitely taken a lot longer than I'd hoped, but we've cleaned up the move class a lot. And in the next video, what we'll do is in the pawn, right, we will go through the hand surgery of generating the en passant moves. So what I would ask you to do as your homework is this, to really make sure you understand this. Go ahead and look at the code that I've written in the pawn class, right? to see where I handle en passant. It should be pretty clear. So there's a couple special moves. There's en passant and pawn promotion. We'll do en passant first. And really what we're doing is that, so every time a move is made, right? So like here, let me actually bring it up in the, let me bring it up in my, in the working version of the application. And then, let's see, open recent. And I think this will make sense, right? So what happens is that the chess engine, the chess board state, we remember when we make a move and we move transition to a completely new board, right? So if you were to look at, for example, execute on any one of these look at, like in execute, we have a new board builder and we construct an entirely new board. That's the board that we transition to, right? So with en passant, what happens is this. Let's say, for example, we go here. When I make this pawn jump move, I set this pawn as the en passant pawn for this board. That's what happens. The board now, the current board has as its en passant this black pawn here. Then, when I want to calculate the legal moves for this pawn, I can go to the board and I can say, is there an en passant pawn? If there is an en passant pawn, then let me calculate it in my legal moves where there's an attack. Then I can take it, right? Hopefully that made sense. We'll definitely go over it again in the next video, but that's what we've been setting up for. That's what all of this has been setting up for. And cleaning up the move class was a prerequisite for that. So I apologize for the, more than usually boring video that I produced here. But it was very important in setting things up. And a couple of you guys have asked me questions about, well, I want to download your code and make it work. It's not working for me. I get an exception. The reason why that is because you don't have a database set up, right? So you can come in here and you can uncheck the use book moves, and you should be able to, after you boot the game, just go computer versus computer and watch it play itself, or you can play against the AI and see how well you do. So anyway, I hope this video was good for you guys. Please do rate, comment, and subscribe, and we will talk to you guys soon. Bye.